Welcome to BKW Physics. I'm Mr. McConnelly. And I'd like to pose a question as we start our momentum and impulse notes for today. If I could throw this ball at, let's say, 30 miles an hour. If I throw this ball at 30 miles an hour at one of you, and you don't know it's coming and it just hits you, you'd be like, whoa, hey, come on, you know, because it's, you know, just a soft cover ball. It wouldn't do too much, but it'd be scary a little bit probably. If a car hits you at 30 miles an hour, that kind of won't see you. Okay? Because what's the difference? They're both going 30 miles an hour.
Intensity.
Mass. The mass makes a big difference here. The velocity is the same. So we've already done this topic, a related topic, of inertia. And inertia was the thing that really meant mass. But now we're just taking it in a slightly different direction. We're going to include not just mass, but we're going to include the idea of how fast the mass is going. Let me go a little bit further. So, if you have two vehicles, let's say one's a small car, and one's a huge semi-truck loaded with stones or something like that. And they're both going down the road at the same speed, okay? And then a deer jumps out in front of both vehicles at the same time, and both the big truck and the small car hit the brakes. Who stops first? Car. Why? You know that, but why?
Doesn't have much inertia.
See, because it's not just the mass, it's the velocity, and it's a combination of the two things. So if you can see from my two examples, there's a little bit more involved when you talk about momentum. And the way you come up with to find momentum is a very simple equation. That's in your reference tables. This funny looking P, which is a rho, lowercase rho, on the side, if you want to see where that is, next to sigma. It's a rho, and it means momentum. And all you do is you take the mass in kilograms and you multiply it by the velocity in meters per second. So then momentum is a kilogram meter per second. And there's really no abbreviation for that. It's just kind of one of those type of units. So if I say I weigh 95 kilograms, if I say I'm running at 10 meters per second, what's my momentum? 5 times 10? 550. Okay? Kilogram meters per second. That's all there is to it. It's a pretty straightforward type of thing. And the number by itself, 950, really means nothing to anybody unless you can kind of relate it to something else. So if you say, I have a 950 momentum, you only have an 850 momentum, and now we're talking about football and they're hitting each other, now you can almost predict who's going to win before we actually bump into each other. Okay, that's where this is going, and that's kind of how it all ties into car crashes too. We're going to do quite a bit with car crashes to help you understand this. But we can take it a little bit further, which is the impulse thing. So if you start with our classic F equals ma, and you think of the A as a change in velocity over time, because remember acceleration is a change in velocity over time, and then we just do a little bit of rearranging by just moving the t over. You'll notice that what I have left on the right-hand side is what? What's this? That is momentum. Okay, fine. Well, what's that? Well, this thing right here, force times time, is something we've never done in the past. We've done, forces, but we've never done them in relationship to time. And when you do force and how much time the force is being applied, the name for that is impulse. Now the actual equation goes like this. Capital J is force times time. This is the way you see it in your reference table. J, believe it or not, means impulse. I know you wish it was an I because it would make more sense, but I is used for something else. It's called current. So, that'll be another lesson. got force is in newtons, and time is in seconds. So what's an impulse? Newtons times second, not per, times. Newtons times seconds. So how can a newton times a second be the same as a kilogram meter per second? Well, if you remember, a newton is a kilogram times a meter per second squared. Okay, you don't need to know this part, by the way. I'm just clarifying something for some people that are confused. How can these two be the same? How can these two be the same, question mark? You don't get it. Here's how it actually works. A newton, since it's a mass times an acceleration, it's a kilogram meter per second squared. And then you're timing that by a second. So what did you end up leaving yourself with? That kills that. You're left with a kilogram meter per second, which is, they are the same. They're equivalent. So a newton second is the same thing as a kilogram meter per second. Not that you really need to know that, because when you're doing a problem and it's this format, you write newton seconds. If you're doing a problem that's this format, you write kilogram meters per second. But you can see they're the same. Alright, let's do one more example here. If my velocity slows from 11 meters per second to 9 meters per second. So if my velocity slows from 11 meters per second to 9 meters per second, and during this time, I'm banging into somebody else, and the time of contact, like we're smashing into each other for 0.7 seconds, how much force did I apply to the person? This is what you can do with these sort of things. So how do we do this? What did I give you there, the 11? Initial velocity. What did I give you there? Final velocity. What did I give you there? Time. So how can I take two velocities, time, and a force, and I got to remind you, remember what my mass was? 95. Because I need that too. So here's all you do. This is really not that bad. You just say, okay, I'm going to take that right there. I'm going to remind myself that momentum is the same thing as impulse. They're equal. Momentum is m, change in v. Impulse is f, t. So the mass, which is 95, my change in velocity is final minus initial. I really would make it a negative 2 probably because of the final minus initial idea. Force, I don't know. And time is 0.7 seconds. So what does it end up giving me? Handy calculator? I can figure that out. Answer? Negative 271? I don't really know because I didn't do it. So assuming my handy student in the front row has calculated correctly, I would have applied a force of 271 to this person if I ran into him for that amount of time, going that fast, all that sort of stuff. What does negative mean then? Yeah, it's kind of like saying whether you're, losing it or gaining it. It's kind of a directional thing. It's a vector thing. So it's not like it's really a negative. It's just more of the direction. So that's impulse and momentum for today.